YouTube channel. In this video, I'm going to show you Form 4, Chapter 4, Heat. As we know, when we were young, we get to know an object whether it is hot or cold by touching. Whenever we touch an object, when it is cold, we will feel that, oh, it's cold. When it's hot, then the sensor in our hand will tell me, oh, it's hot. Now in this chapter, heat, that is related to temperature, where the degree of hotness is used to measure the amount of heat being transferred. So heat is a form of energy. So what will happen is when we touch onto an object, when we feel that it is cold, meaning there is a heat transfer. Okay? Where there is a heat transfer, when it's cold, when we feel that it's cold, heat is transferred from our hand into that object. So meaning the object is absorbing our heat or the energy. That's why we feel cold. Likewise, if we felt it is hot, meaning energy is transferred from an object into our hand. That's why we feel hot. Okay? So first thing you need to get it clear, heat is a form of transfer of energy. Okay? It's a form of energy. And we are using temperature as a form of measurement. Temperature is used to gauge the degree of hotness. Degree of hotness. When it's hot, how hot is it hot? This answers the question of how. Okay? How hot is it? When it's cold, how cold is it? So temperature. To measure that unit, the SI unit, that would be Kelvin, capital K, Kelvin, or in some cases, we'll be using Celsius, C capital. Alright? So, in Form 5 SPM, you get to know this, and in heat, first thing you get to learn would be called zero law. I mean, sometimes later you get to learn this term. It's not in your textbook, maybe you just know it now, called the zero law of thermodynamics. Now, so what's that? It says, what does this actually tells you in zero law thermodynamics? It's all about thermal equilibrium. Thermal equilibrium. What does it mean? Thermal is hot. Okay, the energy is equilibrium. Okay, meaning that's there's no net flow. No net flow doesn't mean that the energy is not flowing. No net flow meaning the heat, direction of heat going in and out is the same, or the amount of heat going into the object and out of the object is the same. It means no net flow of heat. Okay? Between two objects. Between two objects. Okay? Too much of wording. Let's put it into graphical. Say for example, you have a cup of water. Ice water initially is at normal ambient temperature. What happens is you put in some ice cube it floats. Of course, there are waters onto it. Okay, ask yourself, the temperature for this ice initially would be 0. Okay, if this is in solid phase, in solid ice, water, that was 0 degree, and initially the temperature for the water, that would be, okay, I subscribe W subscript, that would be 27 degrees C. Okay, so what happened after maybe half an hour? What happened? The solid ice, I mean the water in solid state, the ice be gone missing. Okay, doesn't know the volume, just an example. And the temperature, you don't expect it to be at 0, neither 27. The temperature T final would be maybe 18 degrees C. So what happened here is all the energy in the water has been reduced as a result of the ice absorbs their initial energy over here, being absorbed, and turns those ice into water, and therefore the overall energy in the water has been decreased drastically. Now those are ambiguous, those are a random number. I didn't do any calculation to it. How do you know the temperature? You know this temperature by using thermometer. Okay, so I hope you know what's thermometer. And well, can't show you an actual thermometer. I mean, you need to attend school and you need to attend laboratory. Okay, there are many types of thermometer. Okay, so some with a laser, infrared thermometer, with but in SPM they standardize it to Mercury thermometer. Okay. Okay, in SPM questions, it's limited to only Mercury. You may have an infrared, yeah, you have thermocouple, yeah, they are all. Okay, there are many types of it. It is in the exam it doesn't come out, but you need to know what are the types of thermometer. So to measure temperature, you use thermometer. So there are gas thermometer, there are mercury thermometer. Okay, there are resistance thermometer. There are thermocouple that I mentioned earlier. Okay, they are of course infrared. Okay, we're not going into that high end. Okay, so where will you use it? Gas thermometer. For gas thermometer, we will use it at you know what I mean? They make use of the gas pressure. Okay, because in some cases you can't use a stick or metal stick to measure temperature. All you need to do is the heat in the air, it will expand. Okay, so you know the gas expansion rate, I mean, how much gas pressure changes, then you will be able to tell what's the temperature. Or for mercury, you make use of the volume change. Okay, the volume of the mercury. For resistance thermometer, make use of electrical. Okay, like in some electrical devices, electrical resistance of platinum. Okay, thermocouple wise is a bijunction effect, a junction effect. There are many types of it. Okay, depending on the range of temperature. For a K type, okay, the general wide range one is a K type. for K-type, you may look for it. What does it mean, a K-type thermometer? It's a chromel alumel. Okay, it's a combination of alloy. I mean, from the negative and the positive side, I mean, you have different combination of alloy. I mean, you need to, if you want to know more on it, alumel and chromel. Sorry, it's the other side. Chromel, alumel, chromel. Wow. Okay, depending on which side is a positive, which is a negative. Chromel, alumel. One side is positive, one is negative. Where it's a chromium, nickel base, and this is manganese, aluminium, nickel, and silicon. Okay, combination, and then you get this thermocouple, and then you're able to use that to measure temperature. But what do they have in common? Why is it possible? Because all of them are said to behave. All of them, this substance. Okay, what happened? This substance varies linearly with temperature. So it means when the temperature increases by 1 degree, the gas pressure, the volume, resistance, junction effect, thermocouple, all of this unit increase by 1 degree. So therefore you're able to use that, correlate that with the increase of temperature. And those are called thermometric property. Okay? Thermometric property. Okay? Thermometric property. Meaning substance varies linearly with temperature. Okay? So next thing, all you need to do is, why do you need that? Because it depends on the application. Okay? Let's say for cooling refrigerator, well, maybe you need to use thermocouple. Cooking in oven, maybe you use gas thermometer, perhaps. Okay? So it depends on your how you want to use it. Things like that, right? So next would be next page. I'm going to bring you on one important, not to say important, that might comes out in SPM, something that you want to put some reading to it, understanding, not reading, doesn't memory anything, memorize anything, is Mercury. Okay? This video would be more towards a very theory. Okay? I mean, it helps you to understand what's going on. Then when you read onto your reference, I hope it helps you to give you a bigger picture. So once you read on it, then you have some idea what to look at. Okay, so thermometer made by Mercury thermometer is the expansion volume. Okay, expansion. These are the keyword. Okay, for objective expansion of mercury. Mercury are used as Hegarium. Hg, Hegarium is scientific name. So the construction, you look at the construction, how it's been constructed. I mean, the building out of it is a small bulb. This is a bulb. Okay, a thin layer of glass, and then you have that long glass tube, and then what happened is inside of it you have this red, I mean some is red, some is gray bulb, and it helps you to see how far it's gone through. I mean, I didn't draw the whole length of it, it doesn't need to know. I mean, I just cut it somewhere here, some idea. So first of all, the characteristic, the building up of this Mercury thermometer is it has one small, very small bulb. small bulb. It doesn't need a huge bulb, because if you have a huge bulb, they will have a huge amount of mercury here, and in order, okay, to really measure the expansion of the volume, what happened, the mercury here has to absorb a lot of heat from the surrounding, then only you will see an increase. So you don't want a big bulb but a small bulb. Okay, so less helium absorb heat, shorter time to respond. Meaning, why a small bulb? Because shorter time or respond time faster. Okay, higher respond time. Okay, more sensitive, meaning it is more sensitive, higher response time. Put on it, then you start to have increase. First thing. Secondly, look at the glass tube, the inner wall. Okay, the inner wall, the glass tube wall, But look at the glass tube wall. What is so great about glass tube wall? It's a very thin glass tube wall. Why? Why is it so thin? It breaks easily, but why you make it so thin? Because if it's so thin, what happens? The heat can be transferred more efficiently. Or we put it in a shorter way, is quick, very quick heat transfer. Okay, even though they know it's a thin wall, then it was very fragile, but yet they need to be very thin so that the heat can be transferred very fast and very efficient. Okay, third thing is, why we were so small? Okay, this inner tube, why can we make it bigger so that it's easier for you to see? Why is it so small? The capillary tube, they call it. What is so great about this capillary tube? This capillary tube has a very fine bore. Okay, fine bore, so that again, complement with the small bulb, so it doesn't need the response time is higher. Last thing, okay, those volume here is not filled by aluminum, not filled by vacuum. It's vacuum. It's vacuum. If you have learned in the previous chapter, you need to be vacuum. Otherwise, what happens? The air pressure will interfere with the expansion. Okay, to avoid interference. Okay, you cannot have air inside this fine bore. Otherwise, the moment you have the increase of volume of this mercury, then the pressure will start builds up, and then it will stop the mercury from expanding. Okay, then last thing, out of the 200 over element in periodic table, why mercury? Okay, standard answer. First thing, is a good heat conductor. It conducts heat very well. First point. Second point, it has high boiling point. Those are the keywords you need to pick up, especially in your objective. Okay, freezing point F is negative 39 degrees C. Boiling point, in order for this mercury to be in vapor form, liquid to vapor, you need to have a 500 degrees C. Okay. Third thing, the thermometric property, meaning it has to be expand. When it's absorbing heat from the others, what happens? You have to expand uniformly, meaning it increases linearly with temperature. The fourth one, opaque. Unlike water, water is not opaque, it's opaque, so that it can be seen easily. Okay, 4 points for them. Okay, so that's something that you need to look at. So if you know this already, things will be much more easier. Next, that would be how to calibrate. How to calibrate. Now calibrate will be very hard, right? Calibrate. Okay. So if you're given a thermometer without a scale, how am I going to read or use that thermometer to measure a temperature? Okay, to calibrate. First of all, calibrate your temperature. Calibrate your thermometer. To do that, simple. Use eyes. Okay. Funnel. Okay. And then a thermometer into here. Fill with ice. Okay, this diagram is available in your reference, but yet I need to show you because I think it's important. Now this is a beaker just to contains the water from dripping around the table. So what happened when it's ice, you put it there, you do not straight away get the reading, because in order for heat to transfer, it takes time. Okay, wait for half an hour or so, measure. So you have this length, isn't it? It goes down to this length, isn't it? After half an hour, you do not expect the heat can be transferred so efficiently the moment even you get the reading. No way to do that. Please answer the questions. Okay, so do not do it because heat transfer takes time. So you measure this height in mm perhaps. This is my length, initial length, L0. And this case, definitely T, is equals to 0 degree C. Wait for it to stable. Okay, first of all, heat transfer takes time. This is something you need to learn and you need to know it. Okay, heat transfer, because heat transfer is all about zero law, thermodynamics. Okay, heat transfer takes time. Okay, this is something that you need to know. Okay, you need to understand something is moving, so it takes time to move, to have a net movement. So that's the zero law. Then what next? The same thermometer will be used to put into the round bottom flux boiling water. Okay. And then it should be here because this is where the steam is going out. Boiling water maybe in the middle would do. Depends on okay, there's some water down here. It's boiling. When it's boiling, the position of this thermometer, sometimes you need to confirm with your teacher whether you need to put it here or in the middle. Okay, in some question that it comes out and asks on where would be the actual boiling point. The moment when it's boiling, the steam comes out, is really, really hot. So I would put it at the same level where the steam goes out. Okay, maybe your school teacher would perceive it different way, but you need to confirm with your school teacher where would you seal it at the top so that there's okay, would it be here or there? Okay, so when it's so hot, then definitely it will it goes up really high. Okay, let's take that as the round bottom flux. Okay, of course you need to have electric heater, then you have a round bottom flux. But for the, heat it up, okay? Heat it up. Let's heat it up. It means heating up. Round bottom flux. I didn't use what is supposed to be a round bottom flux. I mean, you have a holder to hold that. Okay, so what happened is you measure this length, and this would be your final length, and this temperature is assumed, or no need to assume because water boils at 100 degrees. So this is my L100 degree, because at this temperature I assume it to be T supposed to be 100 degrees C. When 100 degree, this length. When it's 0 degree, this length. So now you go to measure your object, and it turns out that your thermometer, the same thermometer, okay, you do not change the thermometer, the same thermometer give you certain height. Okay, so this is an object, and this is the length that you need to measure. Okay, so maybe I'll show the theta. It's a symbol. You need to get used to symbol in physics. Maybe you measure something. Okay, you measure something, some object. Okay, it turns out to give you this length. Oh, not supposed to be flying around. Okay, no. Otherwise, it's not measuring. Okay, no, don't do that. Okay, so this is the length. Okay, you measure, and this is the length. So what happened? It's a direct conversion from above, because when you have L100 is equivalent to 100 degrees C. When you have L0 is equivalent, this length is a known length, okay, 0 degrees C. Now if you have L theta unknown, then corresponding to what? So it's pretty straightforward, isn't it, if I put it this way, correct or not? Right? So what you're going to do would be, first of all, I think the general equation. So you found out the difference, right? The difference here and here. So meaning, draw a line. So the temperature therefore would be, now you use of this length or ratio L theta, you subtract whatever here, L0, the baseline. I will call this a baseline. Okay, if you subtract off this one, then you get the additional one, right? Then we're able to tell what's the difference over L100. This is the length at when the temperature 100, subtract with L0. So this is the total difference of length, and then you times it with 100, because this is 0, this is 100. So you need to minus off the base length, then you know how many grading. So it's at 100, and it's correspond to 100, so we times with 100 degree C. So that's the general equation. Okay, degree C is a unit. Okay, so this is how you should tackle those questions. Okay, normally student would make mistakes here. Okay, they've forgotten how to use it. The known length, the measure length, subtract 0. Always subtract 0 over 100, subtract 0, the one with 0, times 100, then you get the answer. Easily done. Bonus question. Okay. Alright, so water is a very good tool for you to calibrate your thermometer. Okay, so that's all about zero law of thermodynamic heat in Form 4 SPM. So next thing that I will bring in to you would be something called heat capacity. I mean the ability for a material to store energy. Okay, so next thing would be some ability. So just now mentioned is about heat transfer. So meaning that object would have a capability to store energy, so that when you touch it, then energy is either transferred to you or absorbed from you. So next thing is called heat capacity. Capacity meaning ability, isn't it? It's ability to store energy. Okay. What's the ability of energy? I mean, ability of the material to store energy. So how does it happen? What does it mean? It means when an object, when an object is being heated up, meaning you provide heat energy. You provide heat energy to an object. What happened? All the molecule, you need to imagine, all the molecule in between that mass would vibrate, isn't it? Okay? You have vibrate. The vibration increases. So as when vibration increases, what happened? The half mv squared, this is called the kinetic energy. The kinetic energy increases as well. Right now, when it vibrate, increase, so therefore the kinetic energy increase. So when a kinetic energy increase, what happened? The temperature that you read from your thermometer increase. Because why? Temperature is the measurement of the degree of hotness, meaning how much energy is being input into an object. Okay, so what is, I mean, put into a one short sentence. So what does it mean by heat capacity? Heat capacity is the quantity. Quantity. What does it mean by quantity? Quantity is the amount. It's quantity of heat. Energy. Heat is a form of energy. Increase. This is a definition. Okay. Quantity of heat energy. Increase is temperature. Its temperature. By 1 degree C. Okay? Okay. Then how much increase? The quantity of energy absorbed, the mass of any object, or the type of object. So this very much depends on the type of object and the mass of it. Okay? So what is heat capacity is basically like that. Okay? It's quantity of heat increased by 1 degree. Okay. The unit quantity of heat by 1 degree, so therefore the unit would be J heat by degree C, or J over degree K. Now why is it so? Why is the C and K the same? Why is it the same? Because the increment, okay, you look at the Celsius scale and Kelvin scale, they are of the same distance. The scale are the same. That's why it's okay to put Kelvin and Celsius over here, because the scale is the same. You need to read on the reference on it, because they are different scale. I mean, they are different types. Kelvin, Celsius, okay, Fahrenheit, okay, different types of, but in SPM it's Kelvin or Celsius, right? So after you have some idea of heat capacity, object heated, vibration increase, meaning when object is heated, kinetic energy increase, temperature increase. So you need to relate kinetic energy with temperature. Okay, from here, this is what you learn. Kinetic energy increase, temperature increase. That's it. Okay, and heat capacity would be the quantity of heat energy increase its temperature by 1 degree C. I mean, it's an object I refer to. Okay, so next would be under heat capacity. Next thing you will learn is called specific. This is something useful actually. Specific heat capacity. Okay, the wording is almost the same, just that now you have specific. Symbol small c is a small c. It's a dimension here for specific heat capacity, small c. The unit for this c is the amount of energy required, quantity of energy required to increase 1 kg by 1 Kelvin or 1 Celsius. Or put another way to express amount of energy per kg per Kelvin. Okay, specific meaning it has to be divided by a mass. So for actual, definition of it, you may go through it, but simplify it to help you make some short notes from my video. It's actually again the same. It's quantity, meaning how much. Okay, quantity of heat energy require to increase temperature of 1 kg of mass by 1 degree C, okay, or by 1 degree Kelvin. Okay, is the quantity of heat to increase the temperature of 1 kg per 1 degree C. Okay, so because of this definition, there comes up an equation, okay, to help you to remember better. Is the amount of heat is mc theta. Okay, so this C is specific heat that you have learned. Okay, so Q is mc theta, where m is the mass, c is specific heat, theta is the amount of the degree of heat increase or decrease. Okay, so Q represents how much heat loss or gain. Q is a symbol for heat, yeah. Okay, Q is measure heat loss or heat gain, depend on theta. Okay, so it very much depends on what material, type of object we talks about. Okay, so in my next video, I'm looking to talk more on the application of it and the first law of thermodynamics. There are actually only 2 laws in SPM, so don't worry. Or law of thermodynamics, now there are 2. Okay, so before I sum up this video, And you give an example. How do you make use of this specific heat? You could understand the value because we don't have numbers. Okay, you give an example. Okay, let's say if you have some material is 400 joule per kg per degree C, and something 4200 joule per kg per C. Now based on these two values, okay, how do you really understand what does it mean? 4200, 400, what does it mean by 400? Okay, if it were to be 400, it means if you have an object of 1 kg, in order to increase it by 1 degree, you need 400 joule. 400 joule should be sufficient to increase object of 1 kg by 1 degree. Okay, so if you have heat up this material up to, you are providing 4,000 joule. Joule is the form of energy. If you provide 4,000 joule to this material, what happened? The same mass of 1 kg, it will increase by 10 degrees C. Okay. Now, how about the one here? 4200. So this material has a huge or a great potential to store energy, because in order to increase this 1 kg of material by 1 degree, you need to supply at least 4,200 joule. Only then it will start to increase by 1 degree C. Okay, and I hope by that you have some idea what does it mean by specific heat capacity. It's the ability to store energy. So for your information, 400, what's 400? 400 is actually copper, Cu, copper. And H2O is the next one. This is H2O is water. Water. Specific heat capacity, this is a constant you need to know. Water is 4,200 joule per kg per degree C, meaning you need to have more energy in order to increase 1 kg by 1 degree C if we are comparing with copper. Okay, you need to have more energy. So this is how you look at this specific heat capacity, the ability to store energy. Alright, that's all from me. I hope you subscribe to my video. If this is the first time watching my video, kindly press on the thumbs up button. It means you like my video. Stay tuned to my next video. Thank you.